Section 1.2 is about addition of whole numbers. And before I get into the details of the section, I just want to make a comment in general. And as you may have noticed in section 1.1, we introduced new words, so-called vocabulary words. And so these are words that you're expected to remember. For example, what a digit is and what periods are, what place value means, and words like that. In the same way, we'll be introducing new words constantly. And so math being a language, it is important that you retain the vocabulary. And so in most cases, it means you have to keep track of the new words somehow and actively remember the words. Okay? So we begin with the addition of whole numbers. And so first of all, we're going to define the set of natural numbers. So the set of natural numbers begins with 1, then 2, 3, 4, 5, etc. It keeps on going in this pattern. That's what the 3 dots or ellipses means. And there is no largest natural numbers. It just keeps on growing. The next set that we'll be talking about is a set of whole numbers, and it begins with 0, 1, 2, 3, 4, 5, and it keeps on going with the same pattern. And again, there's no largest whole number, and the smallest whole number is 0. So the difference between the set of natural numbers and the set of whole numbers is only one element, and that is 0. Other than that, the two sets are the same, but that's an important distinction. When we add two numbers, let's say 3 plus 2, then each term here is called an addend. Each number is called an addend, and the result, 5, is called the sum. So these are 3 words that are vocabulary words and that you need to remember the meaning of. And how do we add 3 numbers? Let's say 3 plus 2 plus 4. Well, we can first add 3 plus 2 and then add 4, or we can add 3 to the sum of 2 plus 4. Either way, the answer is 9. So this illustrates the associative law of addition. A plus B plus C is the same as A plus B plus C. In other words, the order in which we add these numbers is irrelevant. Further, we can all add numbers in any order. In other words, 2 plus 3 is the same as 3 plus 2, and this observation illustrates the commutative law of addition. In general, A plus B is the same as B plus A. So together, these commutative and associative laws tells us that to add more than 2 numbers, we can use any order and grouping as we wish. Now, when we add 0 to a number, it does not change the number. 0 plus A is the same as 0 plus A equals A. For example, 6 plus 0 is the same as 0 plus 6 and equal to 6. Or you can pick any number, like 198 plus 0 is the same as 0 plus 198 equals 198. And so we say that 0 is the additive identity. It does not change the result of the number. We get the same number for any number A, any whole number A. So next we're going to add 2 numbers, 6,203 and plus 3,542. So what's important, of course, is that we line up the digits, the ones, the tens, the hundreds, and the thousands, and so on. So we add 3 plus 2. We know that's equal to 5. And 0 plus 4, we just learned that if we add 0 to a number, we get the same number. So that would be 4. And 2 plus 5 is 7. And 6 plus 3 is 9. So the sum of the two numbers is 9,745. Okay, let's look at another example here. So here we're looking at a guided solution, 7,968 plus 5,497. So again, we line up the numbers so that the digits match. And 8 plus 7 is 15. So that 15 means 1 10 and 5 ones. So then we add 1 10 to this. So now we add up the tens. And so that's 16. That means 6 tens and 100. So we add the other 100 up on top here. That's called a carry. And so that would be 14. 14 100. So it means 1,000 and a 4. So we put the 1 above the thousands. So then it's 8 plus 5 would be 13 and 1 10,000. 13,465. So that's how the carry works. Similarly, when we add the numbers in example 3, we add 4 plus 8, which is 12. That's 1 10 and 2 ones. So we have extra 10 up here. So 1 plus 0 is 1, and 7 is 8. And then 8 plus 3 is 11. So it gives us a 1, and the 1 carries over to the thousands here. And so we have 16,182. So these concepts carry over to any number of numbers that we add, any number of add-ons. For example, for number 4, exercise 4, we have 2 plus 3 is 5, and 8 is 13, and 1 is 14. So we have 4 ones and 1 10. And so now we add 4, 6, 13, and 17. So we have 7 tens and 100. And this gives us 17, 25, 34. So it's 4 100s and 3 thousands. And when we add these here, we get 10 and 27,474. That is the sum of these 4 numbers. A very simple application of addition is to find the perimeter of an object. And so the distance around an object is called its perimeter. So we'll be using that in the future as well, this word for perimeter. And so here's a guided solution. Here we have an object that measures 4 inches and 5 and 9 and 6 and 5 inches. So in other words, we add 4 plus 5 plus 9 inches and 6 inches and 5 inches. So we count in this direction. We begin here with 4 inches. So when we add this, then we come up as 9 plus 9 is 18, and 6 plus 5 will make it 29 inches. And by the way, it is important when we do an application that we include the units of measure. In other words, it's important to write the word or the abbreviation inches here. So we are adding the same quantities in terms of measurement. And so occasionally you find there's a mixed measure. For example, 6 inches we know is half a foot. So if this were written as half a foot, we need to convert that to inches. We cannot add inches and feet. We need to have a common unit of measure. In this case, we already have it as inches, but watch out when you look at other applications. It may not be that straightforward. And in example number 6, we are supposed to compute the perimeter. So we add 16 feet plus 15 feet plus 16 feet plus 15 feet. And so that would be equal to 31, 47 plus 12 is 62 feet. For example, number 7, we look at index cards, and it says 2 standard sizes for index cards are 3 inches by 5 inches and 5 inches by 8 inches. Find the perimeter of each type of card. Well, let's look at the first one, 3 inches by 5 inches. That also means we have 5 inches on top here, and we have 3 inches on this side. So we have to remember that. So then we add 5 inches plus 3 inches plus 5 inches plus the 3 inches here. So it would be 8, and 5 is 13, and 3 is 16 inches. That would be the perimeter. Similarly, for the 5 by 8 inch card, so 5 inches also on top, and 8 inches rather, and 5 inches to the left. So in this case, we add 8 inches plus 5 inches plus 8 inches plus 5 inches here. And so that is equal to 8 plus 5 is 13, and 21. 8 is 21, and 5 is 26. So altogether it's 26 inches. That's the perimeter of the 5 by 8 index card. And this concludes section 1.2.